Hi guys, so welcome to your lesson 3 video notes. So this is about polynomial functions. So the first thing I'm going to talk about are two facts that were covered already by Mr. Carranza, but I just want to highlight again a couple of things just so that you know that these are super, super important. All right, so fact number 1 is referring to how to find the degree if you just know the terms. All right, so here we can say this has 1 turn, this has 2 turns, this has 3 turns. And again, if you're not sure what I'm talking about, please go watch Carranza's videos because that will elaborate way more on this concept. So to figure out the polynomial degree, right, we can use this expression n minus 1 will equal 1. So that 1 is representing the first term, and the n minus 1 equals 2 represents 2 turns, n minus 1 equals 3 represents 3 terms. And then what you can do is solve for n here, and n will equal 2, n will equal 3, and n will equal 4. And all that means is that that is the potential power for this polynomial. So for example, y would equal x squared here, y will equal x to the third here, and y will equal x to the fourth. Like potentially that could be the highest power. Cool, so that's a review of fact number 1. Now we're doing fact number 2. So fact number 2 says as x approaches positive infinity and as x approaches negative infinity, the highest power takes over. All right, so this is the key thing that you want to have written down. The highest power always takes over. So why is that true? So even though these two graphs, so this is f of x and g of x, even though that in one window it looks different, in another window they look the same, right? And so there's a reason for that, and that's because the highest power takes over. So g of x, right, is equal to x to the third. And if we notice, f of x also has x to the third. So this means that because the highest power takes over, they're going to have very similar shapes when it comes to how they are graphed, all right? So why do we care about knowing this fact? All right, well, this will actually help us to determine the end behavior. So the question here says, answer the following questions about the given polynomial. What happens to the output values for extremely positive values of x? What happens to the output values for extremely negative values of x? So again, when we want to observe that and determine outputs and extremely positive inputs or extremely negative inputs, we're going to look again at the term with the highest power because we know that that takes over, just like what fact number 2 is saying. Once we've identified the highest power, in this case for p of x, it's negative 2x to the third, and then for g of x, it's negative x squared. Okay, we're going to make a table to help us organize our thoughts in identifying the highest power. So we're going to make 2 tables. All right, and so x will represent our input, and then we're going to write negative 2x to the third as the term that will represent, again, the term with the highest power. And then we're just going to randomly pick extremely positive values for x and extremely negative values for x. So extremely positive, let's start with 5, 10, and then 100, right? Those are pretty extremely positive, right? And then here for negative, let's just do their opposites. So negative 5, negative 10, negative 100, all right? And so since this is an input and output chart, we can substitute 5 in and 10 in and 100 in, and we're going to get negative 250, negative 2,000, and then we're going to get negative 200,000. All right, and then when we substitute in the negative values, we're actually going to get the same value, just actually in opposite signs. Now that doesn't always happen, but it just happens for this problem. Okay, and so the whole point of identifying this is that we can see as we get extremely positive, right, these become more negative. So we say that this, so what happens to the output values for extremely positive values of x? We're going to say it approaches negative infinity. Okay, and then here, so as the output values become extremely negative, right? as the inputs become extremely negative, the outputs end up becoming more positive, right? So they end up increasing. So we can say it approaches, right, positive infinity. Okay, and that's it for that answer. Now we would do the same thing over here, and we'll have our two different input-output t-charts, right? And then for consistency purposes, we can use the same inputs and outputs, so -5, -10, -100, and then 5, 10, and 100, right? But this time, instead of -2x to the third, the term with the highest power is -x squared, right? And once you, again, substitute 5 in here, 10 in here, and 100, we're going to get -25, we're going to get -100, and -10,000, right? Okay, so that's very interesting. So here, as again, the extremely positive values of x increases, right? We can see that this approaches negative infinity. So we say it approaches negative infinity, okay? Now for this one, if we do the same thing, right, we plug in -5 in here, we actually get the same output values. We get -25, -100, -10,000. All right, so then, so here, as the x values, right, become more extremely negative, then our output values also become extremely negative. So in this case, this also approaches negative infinity. Okay, so that's all you have to do here when you're doing these kind of problems, right? That's it.